Assalamu alaikum. I am Mohammad Jahangir Alam, lecturer in physics. I welcome you all in my online first lab class. Thanks to Almighty that He has given me the ability to take this class. Dear student, here I also hope all of you are well by the mercy of Almighty and carrying on your regular studies, staying at home. Dear student, today we are going to perform an easy and important experiment, right? And our today's experiment is comparison of EMF of two cells using a potentiometer. Dear student, you know what the EMF is. By the definition we can clarify what is EMF. The potential difference between two terminals of an electric cell in a main circuit is called electromotive force or EMF of the cell. Dear student, according to Ohm's law, you know EMF or potential difference are the same thing. So EMF for the first cell, if denoted by E1, E1 is equal to L1 sigma I, right? And EMF of second cell, if denoted by E2, E2 is equal to L2 sigma I, where L1 and L2 are the distances of the null points from the for the first and second cell respectively. Sigma is the distance of unit length of the wire used in potentiometer, and I is the current due to the electromotive forces, right? Dear students, now we are going to introduce what is potentiometer and other apparatuses required to perform this experiment. Okay, then we have to complete this table. In the table there are 9 columns and some rows. First, number of observation, we will take some observation for the better result. Variable resistance for the first position, second position, third position, resistance of resistance box, then distance of the null point for E1, that is L1. We have to measure the distance from the potentiometer, then average L1, distance of the null point for E2, that is for the second cell, and which is denoted by L2. Average L2, the ratio E1 by E2 is equal to L1 by L2, and average E1 by E2. Dear student, so from this experiment or from this expression we can get the E1 by E2 is equal to L1 by L2. So measuring the ratio of the two length L1 and L2, you know what is L1 and L2, you can get the ratio of E1 and A2, right? Dear student, now let's move to the experimental table. Okay.
Potentiometer. The potentiometer is an instrument used for the measurement of potential difference. It consists of a 10-meter long uniform wire of manganese or constantan stretched in 10 segments, each of 1 meter length. The segments are stretched parallel to each other on a horizontal wooden board. The ends of the wire are fixed to copper strips with binding screws. A metal scale is fixed on the board parallel to the wire. Electrical contact with the wires is established by pressing the jockey J. Principle of potentiometer. A battery BT is connected between the ends A and B of the potentiometer wire through a key K. A steady current I flows through the potentiometer wire. This forms the primary circuit. A primary cell is connected in series with the positive terminal A of the potentiometer, a galvanometer, high resistance, and jockey. This forms the secondary circuit. If the potential difference between A and J is equal to the e.m.f of the cell, no current flows through the galvanometer. It shows zero deflection.
Dear student, first let we see the apparatus for the experiment. This is known as potentiometer. Actually it is an wooden board. Here is a meter scale and conducting wire are connected here. There are 4 connecting point. This point is known as, or this junction point is known as A, then this point is known as B, this point is known as C, and lastly this point is known as D. Then a variable resistance using which we can change the value of the resistance for electric cell, right, among which 2 cell will act like the source of electric current, and the electromotive force of these 2 is to be determined. Then a key or 2-way key and galvanometer, a resistance box, an jockey and connecting wires, right. Dear student, these are the apparatus or required apparatus for the experiment, right. Now let us see the connection of the potentiometer. Dear student, from this point, that is from A point, we have to connect the source or battery, and with which the variable resistance is connected, and other end of the variable resistance is connected to D point. From the same point, that is from A, we have to connect the positive end of the 2 battery cell, of which electromotive force is to be compared, right. These 2 wire are connected to the positive end of the 2 cell, and the negative end of the 2 cell are connected to the 2 ways key. Then from this 2 ways key, a connection is connected to the negative end of the galvanometer. Then from the positive end of the galvanometer, a wire is connected to the resistance box, right, and jockey is connected in the other end of the resistance box, right. This is the connection for the experiment. Okay. Now let us see the reading for the experiment. Here first we have to check whether the connections are okay or not, and to check this, dear student, first we have to place the jockey in the first end of the A point, and you will observe that the deflection in the galvanometer in the right side. Okay. Here the deflection in the right side, and if we place the jockey at the last end of the wire, that is in the D point, then you will get the deflection in the opposite side, right. There are 10 wires in the potentiometer, and length of each wire is 1 meter or 100 centimeters. So total length of the wire used in the potentiometer is 10 meter or 1000 centimeter, right. Dear student, first we have to set a resistance from the resistance box. Here I would like to open this key, and here the value of resistance is 500 ohm. So we are going to write here 500 ohm. Now we will open this key from here for the get to the null point for the first cell, and we have to start from the starting point of the potentiometer. We have to slide the jockey over the wire, that is after sliding 1 meter we did not get any deflection, then you will get start from the opposite direction. Dear student, you have to slide the jockey very slowly because it is a very sensitive reading. I think we are going to get the null deflection in the galvanometer, right. right. Here is the deflection is 0. So in this point, restaurant after sliding 5 times 1 2 3 4 5, that is after crossing 500 centimeter, we start from this side and here the level is 32, that is here the reading of the null point for the first cell is 568 centimeter, 568 centimeter. Okay. Similarly, now we are going to get the reading for the null point for the second cell. Okay. So now we can get almost in the same position. That's when the deflection is almost at the end of the wire 1 2 3 4 5 6, that is here the length of the null point for the second cell is exactly 600 centimeter. Okay. Similarly, we will collect this data and we will get the average value. Okay. Now, dear student, similarly we got the reading for the next two value of for L1. We have got 570, then it was 608, then for the last reading 574 and it was 612. So average value of this three reading is 570.6 and average value of this three reading is 606.6. Okay. So ratio of the two reading is 0.94. Okay. Okay, dear student, now we are going to set a new resistance from the resistance box. Here I open this key and the total resistance is here 500 plus 200, 700 resistance. So here the value of the resistance box is 700, and for the first cell I think it would be okay. I think the deflection is 0 here, and for this reading 1 2 3 4 5 6 600 it is 35, so it will be 65. So null point for the first cell is 665, right? So 665, and that for the second cell we are going to get the null point for the second cell. Right, here is the zero deflection. So 1 2 3 4 5 6 600 and the length is 67, 667, right? Dear student, and the value is 667. Okay. So our next readings are 660 and 650, right? Here for the second cell it was 670 and 675. Okay. And after the 658 and 670, right? So the ratio of these two value will be 0.98. Okay. Now we are going to get the last reading. The value of the resistance here is 900. Okay, 900. And now for the null point for the first cell, here is the null point, and the distance of the null point is 1, 2, 3, 4, 5, 6, 7, 700 and 739. Here the null point is, distance of the null point is 739. 739, and that for the null point for the second cell, I hope we will get it at it is in 775, right? 775. Okay. Our next two readings we have already measured that the null point we have obtained in 745 and that in for the second cell it was 770, then 750, and that for the second cell 760. So the average of this value was 744.6, and that for the this value are 768.3. Okay, and the ratio of these two value is 0.96, right? Now we have to calculate the average of these three value, and after the average we will get 0.96. Dear student, so from the experiment we can say that the ratio of E1 is to E2 is equal to 0.96 is to 1. So this is the ratio of the electromotive force of the two cell that we determined in our today's experiment. Dear student, I hope you got it, but if you have any confusion you can contact with us, you can come to our lab, or you can contact your subject teacher. So we will help you. Thank you very much being with me in my class. May Allah bless all of you. Assalamu alaikum.